Welcome to the Explainer. I'm so thrilled to have you here today because we're jumping right in to look at one of the absolute most essential, but honestly most misunderstood machines operating out in the oil field right now. You know, when most of us think about the oil and gas industry, our minds just automatically go to those massive, towering structures that totally dominate the skyline for months at a time. But what actually happens after those giants pack up and leave? How in the world do you maintain an asset that's pumping away miles underground? Well, the answer is a highly specialized piece of equipment that is entirely defined by its incredible mobility and speed. So get ready to rethink how wells are actually maintained, because today we're looking at the back-end unit.
To really wrap our heads around why this machine even exists, we have to talk about oil field logistics for a second. If you want to move a conventional drilling rig, you're looking at days of intense labor. We're talking a massive convoy of heavy trucks hauling all these dismantled pieces down the highway. It's a huge ordeal. But here's the reality of a producing oil well. Most of the work required over a well's lifespan isn't actually drilling a new hole from scratch. It's fixing what's already down there. Maybe you need to pull a broken pump, or replace some corroded tubing, or just clean out a bunch of sand that's choked off production. And for those kinds of jobs, a 4-day mobilization is completely out of the question. You need a rig that can literally drive itself down a dirt road, back right up to the wellhead, and be standing tall, fully rigged up and ready to pull weight in under an hour. 45 minutes compared to 4 entire days. That staggering contrast right there is exactly why this highly mobile machine is absolutely crucial.
I absolutely love this analogy to really lock this concept in. Think of a conventional drilling rig as a hospital's operating theater. It's enormous, it's fixed in place, it's incredibly expensive to run, and it's the exact place where the patient, meaning the well, is created. Now, think of the back-end unit as the ambulance. It is so much smaller, highly mobile, and it drives directly to the patient carrying a specialized, complete little kit to handle basically everything that goes wrong afterwards. A well is really only drilled once in its entire life, but over, say, 30 years of production, that very same well might be visited and worked over by our ambulance, the back-end unit, 15 or 20 separate times.
Okay, let's dive into this and define exactly what we're looking at here. A back-end unit is, by definition, a portable, self-propelled servicing or workover rig. And the key here is that the entire setup is built directly onto its own truck chassis. The whole shebang is unified on one single vehicle. You've got the engine, the hydraulic mast cylinders, the Drawworks, which is basically just the main hoisting winch, the mast itself, and the operator controls, all integrated together. It is absolutely not designed to drill a new well from the surface all the way down to the reservoir. Instead, it's built to visit existing wells and service them. Now, out in the real world, you're actually rarely going to hear field crews call it a back-end unit. They usually just call it a workover rig or a pulling unit, mostly because pulling heavy steel out of the ground is its #1 job.
Now, I want you to picture something for me. Imagine driving this massive truck down a dusty lease road, heading straight toward a wellhead. It's a single, self-contained vehicle, right? So here's a question to chew on. Why can't the crew simply drive the truck forward, nose first, straight up to the well? Take just a second and really try to picture the geometry of this vehicle. If the entire goal is to position that mast directly over the hole in the ground, what is stopping them from just pulling straight in? Well, the answer comes down to exactly how this machine folds up for transport. The driver's cab is sitting at the very front of the vehicle, obviously, but the mast is actually mounted on a hinge way at the opposite end. That mast can only be swung upward and raised vertically over the rear tail of the truck, so if you were to drive in nose first, you'd end up deploying your massive mast over the dirt road behind you, which is nowhere near the actual well. The geometry of it gives the operator absolutely no choice. They have to carefully, meticulously reverse the entire unit into position, looking over their shoulder the whole time to align the back end perfectly with the wellhead. He backs in. And yeah, that is exactly where the name comes from. Back-end unit is quite literally just a description of how you have to park the thing. So, let's look at how this builds a complete picture of what our oil field ambulance is actually doing out there on a daily basis. These units live their entire lives out on producing oil fields, just constantly jumping from location to location. Their daily grind includes pulling and replacing worn-out sucker rod pumps, swapping out thousands of feet of corroded tubing, cleaning out sand that naturally accumulates down at the bottom of the hole, setting or pulling specialized plugs and packers, and running wireline tools down hole. Because they are just so insanely fast to set up and tear down, a single back-end unit might visit 3, maybe even 4 different wells in one single week.
To put that in perspective, on a mature, aging oil field, these nimble little back-end units handle significantly more well work by sheer volume than large drilling rigs ever could. And this brilliantly illustrates the critical engineering difference here, which brings us to the safety climax of our explainer today. There is a fundamental, unbreakable rule in hoisting. Your mast's rated capacity must always exceed your maximum expected pull. On a massive conventional drilling rig, that mast is engineered to hold 1,000,000 pounds or more. It's staggering. But remember, a back-end unit is essentially just a truck. Its mast rating is far, far lower, usually maxing out somewhere between 100,000 and 250,000 pounds. That is a stark contrast. And what it means is that the operators have a much smaller margin of error when they're pulling stuck pipe out of the ground, which introduces a really unique set of structural vulnerabilities. So the really crucial point here is how we have to think about structural integrity for these specific machines. When a big drilling rig is set up, it almost always sits on an engineered foundation or a deep concrete cellar. It is firmly planted. But our back-end unit, it definitely doesn't have that luxury. It relies entirely on whatever random patch of dirt the driver happened to park on that day. The rig simply folds out its rear jacks and anchors its stabilizing guy lines directly into the surrounding soil. The ground condition and those tension cables aren't just, extra accessories. They quite literally become the structural design of the mast the second it starts carrying a heavy load.
Now, what is absolutely critical to understand here is the fatal failure mode for this equipment. If the ground happens to be a bit too soft and just one single rear jack sinks into the mud while the rig is pulling heavy pipe, or say if the guy lines are left even a little slack and aren't tensioned to the manufacturer's exact pattern, the entire structural geometry fails. The mast can literally buckle and collapse right under the load. Ground condition and guy line rigging are not just some annoying safety paperwork for the crew to fill out and ignore. They are the literal physics keeping thousands of pounds of steel up in the air. All this means that the simple act of spotting the unit, getting it reversed perfectly onto a firm, stable patch of ground, is the single most safety-critical minute of the entire job.
So we've covered the lightning-fast speed, the quirky reverse geometry, the heavy daily workload, and the really unique structural risks of the mobile workover rig. So I want to leave you with this final thought. The very next time you're driving down the highway and you see a steel derrick towering way out there on the horizon, take a slightly closer look. Look for the truck chassis sitting underneath it. Look for those guy lines stretching out into the dirt. Ask yourself, is that massive machine sitting on a concrete foundation slowly building a brand new patient? Or is it a nimble back-end unit, the oil field's ambulance, backed in and rushing to save an existing well? Because I promise you, once you know what to look for, you will never see these incredible machines the same way again. Thank you so much for joining me on this explainer. It has been absolutely great having you here. Keep that curiosity sharp, and we will see you next time.